CPAC 1A, in fact all the CPACs, will have a certain amount of percentage uncertainty associated with any measurement made within it. So we're going to look at CPAC 1A, and we're going to look at all of the different measurements that we took during the practical. The first thing you did in this practical was to make up a standard solution, and the first thing you did was to calculate precisely the mass of sodium hydrogen sulfate required to make up a 0.1 mole per decimeter cubed solution made up to a volume of 250 centimeters cubed. You would have measured the mass out using a balance. The balance would have had an associated accuracy, is that the word? Uncertainty of plus or minus 0.01 gram. There are other balances available. If you use one of those, you just need to make sure that you're using the smallest increment from that balance. For example, if you've got the really good one, expensive one, it might be plus or minus 0.001 gram. So here we've got our balance. Here on top we've got our boat. Now there's one of two methods that you could have used for this. The first method is the one I like to use is tearing or re-zeroing once the boat is on. And what that means is that you've got a value of 0.0 grams plus or minus 0.01 of a gram. The second thing you do is to weigh out accurately the amount of sodium hydrogen sulfate that you want. So this is the actual mass of substance used. Now this, for me, and you'll have a different value to this, I measured it out to be exactly 3 grams, and again plus or minus 0.01 of a gram. So we've got two values here that can give uncertainty. So the total uncertainty for this measurement is going to be plus or minus the combination of these two, which is 0.02 of a gram, divided by the difference in the mass, which is 3.00, take away 0.00, times by 100 to give our percentage, and we get 0.67% uncertainty associated with weighing out the sodium hydrogen sulfate.